Here are a few more quick integration by parts questions. We can start off by highlighting the first term, and then we can follow up by highlighting the second term. And for most of these integration by parts questions, we can definitely set up a table here for the derivative and the integral. So here's the derivative here, and there is the integral column, and I can go ahead and put my x here and e to the 3x. Let's go ahead and find the derivative of x here. So the derivative of x is going to be 1, and then the derivative of 1 is going to be 0. All right, so that takes care of the derivative column. It's pretty quick. And then after that, we can find the antiderivative of e to the 3x, which is 1/3 e to the 3x. And then the antiderivative of 1/3 e to the 3x is going to be 1/9 e to the 3x. So that was a pretty quick table there. And then from there, we can set up another column here on the left-hand side, and we can have the signs here, plus, minus, plus. And then let's go ahead and just highlight the first row there. And then we'll go ahead and highlight the second row here in green. And we can finish off by writing out our final answer here. Okay, so my final answer here, if I go ahead and follow the columns here, I have a plus, I have an x, and I have a 1/3 e to the 3x. So that's going to be written as x times 1/3 e to the 3x, close the bracket. And then let's go ahead and just erase that column because I'm done, or that row. And then if I take a look at the next row here, I have a minus sign here, so that's going to be minus. There's a 1, so 1 times all of that, which will be 1/9 e to the 3x, and then plus c. And if I want to go ahead and just kind of clean this up with one extra step here, this would be 1/3 x e to the 3x, and then minus 1/9, so 1/9 e to the 3x plus c there. So there's your final answer for that particular problem. Okay, let's move on to the next one. This is another one that shouldn't take too much time here. We have an x here and a sine 2x. So let's go ahead and set up a table here. So one column is going to be for the derivative, the other column is going to be for the integral. Usually the first term will denote that for the derivative column, which is x, and then sine of 2x. And then on your derivative column, let's go ahead and take the derivative until it terminates. So the derivative of x is going to be 1, and then the derivative of 1 is going to be 0. So that takes care of the derivative column. And then for your antiderivative, the antiderivative of sine 2x is going to be negative 1/2 cos 2x. And then the antiderivative of negative 1/2 cos 2x is going to be negative 1/4 sine 2x. Let me just extend the line over here. Let me just kind of erase that 0 and just put it right there. And now that my table is done, I can now create the sine table on the left-hand side. So this is going to be plus, minus, and plus. All right, so let's go ahead and let's finish off the rest of this question here. Let's go ahead and highlight the first row here. So plus 1 and negative 1/2 cos 2x. So that's going to be part of my answer there. And then I have another row with the minus sign. Actually, sorry about that. I actually have messed up the order here. Let me go back here again. Sorry. Okay, so sorry. I was supposed to highlight this row here in blue. And then it was supposed to be this row right here. So there you go. That's the proper way of highlighting the rows and following the order there. So I do apologize for that little mistake there. All right, so let's go ahead and write out our final solution here. I have a plus and a minus sign, so that's going to be minus. And then I have an x, so x times all of that now, which is going to be 1/2 cos 2x. And after that, let me just erase that particular row there so I don't get mixed up with the other ones. And then there's a minus sign here and a minus sign there, so that's going to be positive. Positive 1 times all of that, which is just going to be 1/4 sine 2x plus c. Not much you can do here to kind of clean it up. I mean, you can definitely just multiply this through if you like. So that will be negative 1/2 x times cos of 2x, and then plus 1/4 sine 2x plus c as your final answer there. Okay, let's move on to one more and then we'll finish up this homework video guide. Just like the other two questions in this video, we can start off by highlighting the first term and then highlighting the second term. And then we can set up our little table here, derivative and our integral. Usually the first term is going to be the derivative, the second term will be the integral. These examples are kind of nice because when you take the derivative of x, you get 1, and then the derivative of 1 is going to be 0, so you can terminate that side pretty quickly. And then unfortunately for this one, you do have to know your antiderivatives of your trig functions. So the antiderivative of secant squared x is going to be tan x. If you forgot that, you can find that on your formula sheet. And the antiderivative of tan x is going to be ln of secant x. Right, so you might need your formula sheet for those trig identities there, or those antiderivatives of trig functions. Okay, and then just like the other ones, let's set up a column for the signs. So plus, minus, plus. Okay, so I'm gonna try my very best not to make a mistake here. So we need to highlight the first row here, and then I also need to highlight the second row. So negative one times ln of secant x, and then let's just finish off by putting this all together here. So if I have a positive and x and times by tan x, that's going to be x times tan x. Okay, and then let me just erase that. That row is all done. And then I have a negative sign, a 1, and a ln secant x. So if I multiply that all together, I get negative 1 times ln of bracket secant x, sorry, the absolute values, and then plus c here. I guess you don't really need this 1 here, so that would be my final answer here. X tan x minus ln secant x plus c. Okay, so that concludes this homework video guide on integration by parts. Hopefully those 3 examples weren't too bad. Just set up your table with your derivative and your integral columns and just follow the proper steps.